Hello, welcome again. We are solving some questions of fluid mechanics and machinery. The topic is boundary layer flow. Question number 11 to 18 carries a common statement. The statement is the velocity distribution in boundary layer is given by u by u infinity is equal to 2y by delta minus y by delta square. So question number 11 to 18 are the displacement thickness is given by these are the options. Momentum thickness is given by these are the options. Energy thickness is given by these are the options. Shear stress at wall is these are the options. Boundary layer thickness in terms of Reynolds number is these are the options. Shear stress in terms of Reynolds number, these are the options. Drag force is given by these are the options. Drag coefficient is given by these are the options. Okay. So here the space u by u infinity is given as 2 by y by delta minus y by delta square. Okay. So the displacement thickness is given by delta star is equal to 1 minus u by u infinity multiplied dy and 0 to delta. Okay. So substituting the value of u by u infinity, that is 2y by delta minus y by delta square. Okay. So this will be your 1 minus 2y by delta plus y by delta square. Okay. So if we integrate it and put the limit delta to 0, we can find out the displacement thickness. So that will be y 2y square by 2 delta y cube by 3 delta square, and if we put the limit, then we get delta star as delta by 3. So displacement thickness is delta by 3. So answer to question number 11 is option A. Okay. Next question is momentum thickness, and momentum thickness is given by u by u infinity bracket 1 minus u by u infinity bracket close dy and limits of integration delta to 0. Now we can put u by u infinity as 2y minus delta minus y square by delta square, and again, and now multiplying these two terms, we get 2y minus 2y by delta minus 4y square by delta square plus 2y cube by delta cube minus y square by delta square, 2y cube by delta cube and del y 4 by delta 4. So now integrating it will be y square by, so solving it, okay, so it will be 2y minus 2y by delta, and here this is y square term and here y square term, so it will be 5y square delta square, and similarly this will be 4y cube delta cube from this, and this will be minus 5 or y to the power 4 delta 4. So solving it, integrating it, that will be 2y square by delta minus 5y cube by delta square plus 4y 4 by delta 4 and minus 5 y 5 by 5 delta 4. So putting a limit, we can get momentum thickness as 2 delta by 15. Okay. So momentum thickness as 2 delta by 15, that is answer is option C. Next one is energy thickness. So energy thickness is given by delta double star y u by u infinity bracket 1 minus y by y infinity square dy, and it will be 2y minus 2y by delta minus y square by delta square 1 minus 2y by delta minus y square by delta square square. So multiplying these two terms, we get this 2y by delta minus 8y cube by delta cube minus 2y 5 by delta cube, 8y 4 by delta 4 minus y square by delta 5, 4y 4 delta 4 plus y 6 by delta 6, and 4 by 5 delta 5. Sorry, 4 by 5 by delta 5. So solving this and integrating it like this, and then putting a limit, we get momentum thickness as, sorry, energy thickness as 22 delta by 105. Okay. So next is shear stress at the wall, and shear stress at the wall is given as tau naught equal to mu du by dy y naught, and u is given as u infinity 2y by delta minus y square by delta. So differentiating it and we get du by dy u infinity, and it will be 2 by delta minus 2y by delta square. Now putting y is equal to 0, because we have to find out the shear stress at wall, so it will be 2 u infinity by delta, or putting here this value, so shear stress at wall will be 2 mu u infinity by delta. Okay, so von Karman, now next is your question number 15 is boundary layer thickness in terms of Reynolds number. So boundary layer thickness in terms of Reynolds number can be found out by using von Karman relation, that is tau naught by rho u infinity square is equal to curly theta by curly x. Theta we have find out this. Theta is the momentum thickness, that is 2 delta by 15. Okay, 2 delta by 15, or and tau naught we have found out this 2 mu u infinity by delta. So putting this value and differentiating curly theta by curly x, and by partial differentiation we get 2 by 15 curly delta by curly x. Okay, so it will be delta, and now we can take this delta x here and delta here, so it will be and integrating, then it will be delta square by 2 plus 15 mu x by rho u infinity plus c. So at the edge x is equal to 0, delta is equal to 0, and hence c is equal to 0. Okay, so delta is your 5 point, following this, delta is your 5.48 mu x by rho u infinity, or we can multiply here x and divide it by x. So now this rho u infinity x by mu becomes Reynolds number. So boundary layer thickness in terms of Reynolds number is 5.48 x by root RE. So next is shear stress in terms of Reynolds number. So the shear stress expression we have found out, this is tau naught equal to mu u infinity. Okay, and now we have to find out delta in terms of x. We can put here delta and find out shear stress in terms of Reynolds number, that is 0.365 mu u infinity x by root RE. Okay, next is drag force. So drag force is shear stress multiplied by the area for a small strip. This is the force, and if we integrate between 0 to L, okay, between 0 to L, then we can find out the total drag force. So value of tau naught is this in terms of Rex. So Rex can be changed into rho u infinity x by mu root, to take the term in the term of x and other constants. So now this rho u infinity, mu u infinity, mu b are constant, and only variable is this. So we can integrate it. So that is x raised power 1 by 2 by 1 by 2, and limits are L to 0. So the drag force comes out as solving this comes out as 0.73 b mu u infinity root rho u infinity L by b. Next is coefficient of drag. The coefficient of drag is nothing but fd by half rho a u square. Okay, fd we have calculated, that is 0.73 b mu u infinity. Okay, into this this, okay, and a is your L into b. So CD is your 1.46. Now this can be written as REL. So the CD is your 1.46 divided by root REL. So answer is option B. Okay. So just like the first question, it is the same formulas, but expression for u by u infinity are different. So that is the answer.